So in this video, what we're going to try and do is create a function in Matlab which takes the inputs of a cone radius and side length and outputs the volume of a cone V. So what we've been given here is something to help us calculate the volume. So we can see that V is equal to pi times r squared, where r is the radius of our cone, and that's something that we were given. And then h is going to be the height of our cone, right? And this is something that we're not directly given. Instead, what we've got is the side length, this L value down the side. So, in order to calculate the volume, we're going to need to first find what the height is, and then we can use that to substitute in. So what I'm going to do as a pre-step is figure out what this h value is using the triangle, and it should just be like Pythagoras' theorem. So it's like a squared plus b squared equals c squared. So here we've got h squared plus r squared is equal to L squared, where L is that hypotenuse of the triangle. So we want to get h, so we should be able to rearrange. And then we're going to get h is equal to the square root of L squared minus r squared. So this is going to be one line that we need in our code, and then we should be able to do this second line over here in order to calculate the volume. Alright, so let's jump back over to Matlab. And what I'm going to do is start a new script file, and it should open up a window here. So we're making a function file, so what we need to make sure we do is type in the keyword, which is function. That's telling Matlab that we're creating this as a function. And then the syntax is that we need to put the outputs in square brackets equals, it's going to be the name of our function. So let's call ours cone volume. And then in the rounded brackets here, we're going to put the inputs. So our output to our function is going to be the volume, and we're going to use capital V for that. And then for the inputs, what we said is that we have the radius, which we were calling R, and we also had the side length, which we called L. All right, so that's the syntax that we need to use in order to correctly define, I guess, our function. So it's just outputs in square brackets, name of your function, and then inputs in the rounded brackets. So one thing that is kind of critical for when we run this in a moment is that the name of our function, it needs to make sure that we start with a letter of the alphabet. It can be lowercase or uppercase, but it can't be a number or anything else. And what we need to make sure is that there's no spaces in the name of our function, otherwise it won't work. Okay, so there are two kind of common mistakes that people make. And what we were going to do is when we save this now, we want to make sure that the file name that we give it is the same as the function name, otherwise it won't work either. So I'm going to click save here. All right, and so now we've saved our function code. Alright, so at the moment it's complaining at us because we haven't used any of these variables that we defined. So that's what we need to do underneath in here, is actually plug in those equations that we wanted. So we said that the first equation that we needed to use was this one here that had h in it. So we need to define h equals the square root of L squared minus r squared. So jumping back, let's type that in. So the left-hand side is always what you want to designate, and square root is the name of the square root function. And you can see here, if you highlight or hover over it, it will pop up what it's expecting. So it just wants the value that you want to take the square root of. So ours is going to be L squared minus r squared. Okay, and of course both of these values are going to be drawn in from the inputs up here. So in Matlab, if you want to suppress a line from being outputted down in the command window, you need to just put that little semicolon on the end. Alright, so now we're up to our second line, which was calculating the volume of our cone, not pyramid. So we just need to program this equation here. So again, left-hand side is what you want to designate. So we've got V that we're trying to define, and then pi in Matlab is just pi, it knows what that means. And then we need to multiply it by r squared, multiply it by the h that we just found in the previous line, and divide it by 3. And again, so that it doesn't output that to our command window, what we can do is put the little semicolon on the end. Alright, so I'm going to save this and we're going to test it and see what happens. So in order to test it, I'm just going to copy this bit of our function and paste it down here. And what we need to do is actually define what R and L are so it can run it. So let's say that I put, I don't know, the numbers 1 and 2 in here. So that means that the first one, it's reading as the R value, and the second one here, it's reading as the L value. So if I hit enter now, what I should find is it's going to run it through this function code, and it's going to return to me the output, which was just V in this case. All right, let's just do a little quick check. If I took this off, what we should see is that this intermediate line is going to spit out down here. So if I hit up, all right, that's going to call back the previous line. And if I run again now, hit enter, what we can see is that it has outputted this H value simply because I didn't have that little semicolon on the end to suppress it. All right, and then it's returned V because that was the output of my function here. So that's pretty much all there is in terms of defining a function. If you want, one thing you can do is put an end on the end here within your function file just to tell Matlab that that is indeed the end of your function. But when you just have one function defined within a script file like this, it doesn't really matter. Matlab assumes that that's what you mean. So that's all there is in terms of this video. Thank you.